So this is another session from electrochemistry. In this session we are going to discuss 3 points. What is first one? Nernst's theory for development of electrode potential, means how oxidation and reduction potential is developed. What is second one? Nernst equation with meanings of the terms involved in it. And last one, how to modify this Nernst equation for these two phenomena. What is first one? Oxidation. And what is another one? Reduction. So let us start with first part. So this is got a question for board exam and tabular form. From this theory discussion we are going to use in MCQ part. So in order to explain development of two potential, oxidation and reduction, this theory can be used, known to be Nernst's theory of development of electrode potential. So what is first one? This theory explains development of electrode potential, maybe oxidation or reduction, depending upon two phenomena. What is first one? This is in front of you, de-electronation. What is second one? Electronation. So let us start with first case, de-electronation. Can you tell me what De indicate? That is removal. So removal of electron means simply it is nothing but oxidation. So phenomenon or the process of removal of electron or loss of electron is called as de-electronation. Now check this condition. If we check this construction, this is what? Zinc rod. It is in direct contact with which solution? ZnSO4 solution. So what is our first construction? Zinc rod in contact with ZnSO4 solution. So in this case, what happened? Zinc shows tendency to pass into solution in which form? Check this one. Zn gives rise to Zn plus 2 plus loss of 2 electron. What loss of electron called as de-electronation. So remember in this case, zinc shows tendency to pass into solution in which form? Cation. So here what we can represent? Positive charge. Then what about electrode? This carries opposite charge, that is negative charge. So in this way what happened? There is formation of electrical double layer, and that electrical double layer is responsible for potential, and that potential is called as oxidation potential. So remember here, zinc pass into solution in the form of cation, and this tendency of zinc to pass in the solution in the form of cation, it is denoted on paper by PS. What is PS? This is solution pressure. So remember diagrammatic representation, reaction, and what is this tendency? Solution pressure, that is PS. Check next one. What is second condition? Electronation. So this is reverse of de-electronation. Can you tell me? Phenomenon or the process of addition of electron or gain of electron. This is called as electronation. So let us start with another construction. Suppose we consider copper rod. This copper rod is in contact with CuSO4 solution. So what is our construction? Copper rod deep in copper sulfate solution. So in this case, remember, instead of passing into solution in the form of cation, what tendency is observed here? Copper plus 2 ion accept 2 electron to form metallic copper. What is gain of electron? Electronation. So in this case, tell me, what about electrical double layer? This solution carries negative charge. What about electrode? This one carries opposite, that is positive charge. Once again, there is development of electrical double layer across the electrode, and this electrical double layer is responsible for potential, and that kind of potential developed, it is called as reduction potential. And what about this symbolic notation? P0 or PO, it is called as osmotic pressure. What is osmotic pressure? Instead of passing into solution in the form of cation, copper ion shows tendency to get electron and get back deposited. This tendency is osmotic pressure. Check last condition. What word itself suggests? We are going to consider here which electrode? Null electrode. So in this case what happened? Suppose this is under study metal rod. It is deep in metal ion solution. So in this case what happened? Rate of these two phenomenon. Which one? De-electronation. It is equal to rate of electronation. Means what happened? This solution pressure equal to osmotic pressure, and as per earlier discussion magnitude will be same and change of sign, so these values get cancelled with each other and water may be the net potential developed, that will be 0 volt, and such construction is called as which electrode? Null electrode. So try to remember, de-electronation responsible for oxidation potential, electronation responsible for reduction, and when solution pressure equal to osmotic pressure, what is potential? 0 volt, and such assembly is called as null electrode. Let us check next point. So for MCQ purpose, these three conditions are very important. What is first one? If PS is greater than PO, means solution pressure is greater than osmotic pressure. Ultimately what happened? Rate of de-electronation is high. Means oxidation takes place easily and water may be the potential developed across electrode. That is called as which potential? Oxidation. How to denote this on paper? Standard oxidation potential. What about reverse condition? If solution pressure is less than osmotic pressure, ultimately what happen? Rate of electronation will be higher and potential developed is called as which one? Reduction potential, that is E0 reduction. And just we considered here, what is third case? If solution pressure equal to osmotic pressure, then what happen? These two phenomena, which one? De-electronation and electronation. The rate of these two phenomena becomes same and potential developed will be 0 volt, and such assembly is called as which electrode? Null electrode. So remember, PS greater than P0, oxidation potential, PS less than P0, reduction potential, and PS equal to P0, 0 potential developed, that is null electrode. After this, check another important part, that is Nernst equation. So check original form of Nernst equation, that is in front of you. What it indicate? E equal to E0 minus 2.303 RT by NF log concentration of product upon reactant. So can you tell me meaning of the terms? E indicate EMF of the cell. What E0 indicate? Standard EMF of the cell. What small n indicate? Number of electron transferred. In oxidation there is loss, in reduction there is gain. What about this one? R, gas constant, T absolute temperature. What is F? Faraday. And remember, 1 Faraday equal to 96,500 coulombs. So check this ratio for MCQs also. 2.303 RT by F. This ratio equal to 0.0591. So how to modify this original form? What we can write here? Therefore, E equal to E0 minus 0.0591 upon N. And what about this ratio? Log concentration. Which one? Concentration of product, that is oxidized form, divided by concentration of reactant to the base 10. So remember, this ratio equal to 0.0591, so that we can modify this relation in this way. What about meanings? Just we consider. E is EMF, E0 is standard EMF of the cell, N indicate number of electron transferred, lost or gain, and F equal to Faraday of electricity. And remember this one, 1 Faraday equal to how much? 96,500 coulomb. This is very important relation for MCQ discussion. Check another point. How to modify this Nernst equation for these two phenomena. Which one? Oxidation and reduction. So what is in front of you? Zinc undergoes oxidation to form which ion? Zn+2. Loss of electron called as oxidation or de-electronation. This is what we are having, original form for Nernst equation. Then how to modify this Nernst equation? In this case, what n equal to? N equal to 2. How? 2 electrons are transferred. So put that value here, so that what you will get? E equal to E0 minus 0.0591 upon n equal to 2 log. Tell me here, what is product? Zn plus 2. So what we can write? Concentration of Zn plus 2. What about reactant? Zn. So this is concentration of Zn. Then check this support. But concentration of pure metal is always taken to be unity. So this zinc metal concentration taken to be 1. So what should be last step? What we can write? E equal to E0 minus 0.0591 upon 2 log. What is this? Concentration of Zn plus 2 ion to the base 10. So this is what we are having. Final Nernst equation for which process? Oxidation. Similarly, check another one. What is this? Reduction. What happened in this case? Copper ion, Cu plus 2 ion accept 2 electron to form Cu. Metallic copper is obtained by which phenomenon? Reduction. So how to modify this one? Again, this is Nernst equation in front of you. Tell me changes. Here n equal to 2. So what we can write here? Number of electron gain 2. So how to modify this? E equal to E0 minus 0.0591 upon 2. What about ratio? Log. What is product here? Metallic copper. What is reactant? Cu plus 2 ion. So this is what ratio? Product upon reactant. Once again, what is our condition? Concentration of pure metal is unity. So if metal copper concentration taken to be 1, so what should be last step in this case? A equal to E0 minus 0.0591 by 2 log. Tell me here, this pure metal copper in concentration unity. So in this case, which value to be considered here? Reciprocal of copper ion concentration. This is considered for log. So this is Nernst equation for which phenomenon? Reduction. Then check last point. What are the two types of cell? In day-to-day life also you come across these cells. Which one? One is primary cell and what is another one? Secondary cell. So can you tell me by example dry cell? This is use and throw type of cell. What is this? Battery, that is storage cell. This is secondary cell. Dry cell is primary cell. So try to remember what is primary cell? Cell which itself generate electricity. And it is what type of cell? Irreversible. Means it cannot be charged and used again and again. So such use and throw type of cell called as primary cell. What is example? Dry cell. What about last one? Secondary cell. Reverse this wording. Cell which itself cannot generate electricity. Means whatever may be the electricity stored in the cell during charging, that stored electricity it supplied. And what about its nature? It is reversible cell. Means it can be charged and used again and again. So such type of cell called as which cell? Storage cell. That is secondary cell. So tell me last part.